So when we're finding angle measures, it's all about recognizing what are the vertical angles and what we need to subtract them from, and so on. In this particular case, IAK is 69 degrees. Okay, so we're looking for GCJ, the angle, the blue angle down the bottom. Okay, if we notice first of all that these two lines are parallel, that will tell us that the line that transverses them is cutting these two and creates congruent angles all across. It also, we know that the line KL to DE is also perpendicular, which means that we've got a 90-degree transversal also, which means that we know that this 69 degrees, we can actually subtract it from 90 degrees, and that's going to give us the measure of an angle which we can find useful. So we subtract 69 degrees from 90, we of course get 21. So this angle right here is 21 degrees, completing the 90-degree angle, which means its vertical angle is also 21 degrees. And so the adjacent angle is 21 degrees, the vertical angle is 21 degrees, so the corresponding angle is also 21 degrees. And there we have it down there. Okay, in this particular case, we have another mathematical proof that tells us about the external angles to triangles, and this one is a little bit more interesting because even though we can work it out without knowing the external angles theorem, we can find a quicker way of doing this as well. So we know, first of all, that this is a straight line. DC is a straight line, so therefore 180 degrees minus 126 degrees is going to give us 54 degrees. And we have 54 degrees inside there, and we've got 62 degrees in the angle ABC, which means that we could add those together to find out what the measure of angle ACB is, because we know that the internal angles of a triangle add up to 180 degrees. So just doing 62 plus 54, that of course is going to give us 116. Be careful, not 126 in this case, 116. Okay, so 62 plus 54 gives us 116, and therefore then 180 minus 116 is going to give us 64. So the measure of angle ACB is 64 degrees. Now, if we are observant, we will notice that 64 plus 62 so that's 62 plus the 64 we just found out actually add up to 126, which makes a lot of sense, really, because the internal angles of the triangle are 180, the straight line is 180, so all we really needed to do was do 126 minus 62, and that would give us 64, and that is the quickest way to do that in this particular problem. But it's good to know the math behind it also. In this problem here, we have a similar situation, a very similar situation. In fact, we have the external angle problem again, and we know that the internal angle 69 degrees plus the angle we're looking for, the measure of ACB, is going to be equal to 129 degrees. That's what the previous question told us also. So in this particular situation, we need to just manipulate this equation a little bit so that we can find out what the measure of ACB is. And we know that by subtracting 69 from 129, we will get the measure of the angle ACB. So 129 minus 69, those 9's give you 0, and borrow the 1. So we have 60 degrees total for the measure of the angle ACB. And that is the quick way of doing it without the rigmarole of the previous question. Just take note that 180 degrees minus 129 degrees is, of course, 51 degrees, and that gives us, when we add up the three measures, the angles inside the triangle, we notice that we end up with 180 degrees, as is expected. So a bit of error check is also a good idea from time to time. This situation here, we of course have A, B, and C, D are two perpendicular lines, so we know they create 90-degree angles, so we can subtract 67 from 90 degrees, and that is going to give us the adjacent angle, which of course is 23 degrees, which means that a vertical angle to that adjacent angle is also going to be 23 degrees. So the next problem, again, we have two parallel lines, DE and FG. We've got the vertical, the perpendicular transversal KL to DE. KL is perpendicular to DE. So therefore we have a 90-degree angle to work with, and it means we can subtract this 57 degrees, and that will give us 33 degrees for the adjacent angle. Now we know also that this angle is vertical to the inside angle, which of course is a corresponding angle to the angle GCJ. So therefore the measure of the angle we're looking for is of course 33 degrees.